In this video, I'm going to cover both examples 5.5.1 and 5.5.2 on differentiation of vectors. Here we're given two vectors and we need to find the first derivative with respect to time and the second derivative with respect to time. So for part A, looking at each component separately, differentiate t squared, we get 2t. Differentiate 4 cos t, and we get minus 4 sine t. So then we can put them together to write down the answer. So the first derivative, dA by dt, is going to be 2ti minus 4 sine t j. Differentiate again to get the second derivative. Again, I'm going to look at each term separately. Differentiate 2t and we get 2. Notice I'm ignoring the i's and j's at this stage and putting them back in at the end. Differentiate minus 4 sine t and we get minus 4 cos t. Now put them together. This is the I component, this is the j component. So 2i minus 4 cos t j is the second derivative with respect to time. It's the same process for the other question, part B. It's in 3 dimensions. Separate each term and then put them all together at the end. So differentiate e to the minus t, we get minus e to the minus t. Differentiate t cubed, we get 3t squared. Differentiate 4t squared, we get 8t. And then this is the I component, j component, k component, and there we have our first derivative. When you're writing these, make sure you are underlining I, j, and k because they are vectors. Also, a is a vector. You can see here a is defined in terms of I and j, so a is a vector. So a, I, and j need underlining. If you're handwriting, if you're typing, you can make them bold. Second derivative, differentiate the I component, differentiate the j component, differentiate the k component, and then put them all together, and we have the second derivative. So that was example 5.5.1. Now example 5.5.2. Given that a is a constant vector, find the derivatives with respect to t for time, of these two terms here. So a is a constant vector. If it was in 2 dimensions, so a could be something like 3i minus 5j. That would be constant. There's no variables here. I and j are fixed unit vectors. They are not variable. So that's just one example of what I could be. So t squared a, we differentiate it. We can go straight to the answer here. So it's going to be 2ta. And for the second one, we've got a couple of terms here. If we wanted to, we could factorize out the common factor of a. So this is the same. I haven't differentiated. This is the same as what we had in the line above. So you could write it like this first and then differentiate the inside of the brackets. We don't need the product rule because a is not a function of time. It's just a number, just a constant. I'm not going to rewrite it like this, but you could do if you wanted to. I'm just going to differentiate each term separately. So this goes to 3t squared a minus sine t a. Once again, if you wanted to, you could rewrite your answer by taking out common factor of a.